Hello everyone. Last week you watched Zach give an introduction to the Engage content creator. We saw some of the useful features Engage has to allow puppeteering to make scenes come to life. Today, I want to give a similar introduction to LiDAR and photogrammetry so y'all can make 3D objects out of real life objects and bring them into virtual reality with as little as a smartphone. So let's jump right into it. First, let's get into LiDAR. You've probably heard LiDAR in some science articles or in your engineering classes if you've taken one. But what is it? LiDAR stands for light detection and ranging. LiDAR is a ranging system that measures the distance of an object through laser pulses. The time lapse between outgoing and incoming pulses is measured against the detection of the reflected light pulse. In other words, the LiDAR sensor emits laser signals out and it measures the time it takes to come back. Think of whales and echolocation. By analyzing the distance of an object, precise models can be mapped with that data. Where do we see LiDAR in the real world? Well, in a lot of places, from consumer to researchers. LiDAR is often used by companies that are attempting to create fully autonomous cars. Here we see the Google Waymo project. The LiDAR system in this car is used to be able to effectively avoid road objects, pedestrians, and be the eyes of the car. LiDAR can also be used for scanning topography of large areas of land. LiDAR-equipped planes have been used to map much of the Amazon rainforest, as the LiDAR can see through the heavy leaf canopy. Through this, there has been many archaeological finds deep in the Amazon. This is all super cool, but if you're wondering how much does a full LiDAR system cost, well, it's pretty expensive. The Amazon project I told you about costed a few couple $100,000. If you want to have a LiDAR equipped device in your car, that's going to run you about $10,000 USD. Or better yet, if you want a LiDAR drone to scan the topography of a mountainside, a Matrix 300 RTK with a Zenmuse L1 LiDAR module is going to be right around the $20,000 range. But this isn't always the case anymore. Why? Because since the iPhone 12, the Pro models now come with a LiDAR sensor in the back. While this is meant to be for the camera to optimize autofocus, it can do much more than that. For as little as $750 USD in the used markets, you can have some of the features too. And chances are you might already have one of these phones right now. So let's move into some screen recordings that I did of myself going out into my neighborhood and scanning a post in a park using LiDAR. As you can now see, we're on my smartphone. And I'm using an app called 3D Scanner app to leverage the LiDAR scanner on my iPhone to scan this post in this park near my house. As you can see, I'm trying my best to rotate around the object while remaining fairly consistent in distance. You can notice the object is being covered in purple. This means that it's been picked up and is being modeled by the app using the LiDAR scanner. But I'm going to go ahead and keep attempting to scan for more details. You can see that these aren't the most ideal conditions to scanning. You can see brushes, plants, branches, and trees all around. But I chose this specific spot to reassure you guys just how easy it is to go outside into your backyard or park and scan and explore and bring stuff into virtual reality. I didn't have the most perfect environment with the best lighting, but here I am trying. So you can do the same, and as you can see, I finished my scan. And we can see a pretty rough mesh model. But I'm going to go ahead and process that and show you guys the object. This one in specific is not the best model that you could get, but you saw it live. This is my first take. And for your first take, it's a pretty good object. You can see pretty good detail in the bottom concrete foundation, in the back post that I was barely able to capture, as well as in the overall graffiti throughout. But here you can see that I'm opening up some of the other objects, some of the other options that are in the app. And one thing I'm going to do is I'm actually going to go ahead and extend the scan to see if I could pick up any other details in the object itself or the environment. So as you can see, the app actually went ahead and picked up the mesh of the object. So it's going to go ahead and try to scan any other details in the nooks and crannies that I might have missed in the earlier scan. As you can see, I'm taking a similar approach to circling around the object, trying to pick up any of the extra fine details that I might have missed in the first attempt. We're almost there. One more second, guys. I'm trying not to jump around too much with edits, just so you guys can see just how easy the process is. So that's finished, and here we have the updated mesh. I'm going to go ahead and process that once again. Should be relatively fast. And here we go. Now it's not the biggest change, but there's some slight details that are updated from the previous mesh model. But again, this is a very fast scan in not the most ideal conditions, so it's pretty good for what we have. And here you see some of the other options that there is to simplify or to sharpen, but most importantly, I want to look at the sharing object options, because you can actually share this as an OBJ, a GOB, or it's a Sketchfab. That was really interesting, because before I even get home, I could upload that object to an online marketplace, and now anybody all over the world can now use that object inside of their environments or download that to edit it. And by leveraging the Apple AR kit, now we're going to see that I can actually bring the scan I took of the post into my camera view and place it right next to the post. Again, guys, for a first try, this looks pretty good. Of course, some small imperfections can be cropped out, and like the colors can be adjusted a little bit, but you guys saw it live. A 40-second scan gave me an object that looks pretty realistic. Here we go, just trying to size it up a little bit so it looks a little more realistic, a little more identical. And I'm going to go ahead and take a picture. Here we are again analyzing the actual 3D object. Again, really fast. Most importantly, this was free. And I actually want to do a second take to kind of show you guys that you don't always need the most ideal conditions. All you need is a few seconds to stop, point and shoot, and you can have a full rendered object. So here, right next to the post, I found this little like water runoff that goes into the little lake or river behind me, and I thought it was really cool, and you know, it might be useful in an environment where we're talking about sewage or anything else. So I went ahead, I scanned it. Again, this is no crops, no edits. I'm not speeding anything up, or I'm not making anything shorter. This is all in real time. You're seeing exactly what I was seeing. It's going to go around me. You can see my shadow on the floor. Kind of make sure you get all the angles, to get all the details and all the nooks and crannies. And here, and that's being processed. Because you can see me walking away now. But that's the ultra rough mesh. Once we process this, then you're gonna see that it's gonna look so much better. Again, we're not cropping any of this out, just to show you guys in real time how long this takes. Almost there. One more second. 2 more seconds maybe. Maybe 3. Here we go. Okay, so as you can see, this is a very detailed. I mean, look at that. You can see the indents in the concrete, the details in the actual lids. For another 40-second scan, this is a really good object. With some minor cleanup around the edges, this could be used in any environment. And now I actually want to go into photogrammetry, because you don't always need the newest iPhone to participate, because there's photogrammetry. What is photogrammetry? Photogrammetry is a technique to obtain reliable data of real-life objects in the environment by creating 3D models from photos. Software takes these photos and creates point clouds, estimating the distance between the camera and the object to create the object. Photogrammetry is used in a lot of areas of the real world, from construction and engineering to follow the process of a build and report on it, to game development and movie studios to create hyper-realistic environments, and interestingly enough, in forensics to document real-life crime scenes. Now let's go on to my phone again to see how I use photogrammetry to make a digital object. Alright everybody, as you can see we're back on my phone. I'm on the App Store and I'm going to open up an app called Polycam. Keep in mind that this app is also available on the Google Play Store for Android devices. So when I open that up, what we're going to see is we're going to see three main options at the bottom and two options to the left. The three in the bottom are essentially the three modes you have. You could use either LiDAR, as you can see I'm moving my camera phone around and it's picking up the actual topography. You could use the room one, where you can actually convert your room into an actual like walkable kind of map of sorts. But most importantly, I want to use a photo one. As you can see, I'm toggling back and forth between the manual and automatic. Essentially, that gives you autonomy over the actual shutter and if you take the photos manually or if the app is doing it for you. So I'm going to go ahead and begin. And as you begin to notice, the app starts to take multiple photos as I circle around the object. This is because the photos is what we're going to use to create the renders later on. The more photos we have, the more data we have to work with.
So I'm going to go ahead and do the same motion I did with the LiDAR and just rotate. I'm going to go around. And for photogrammetry, it's best to really get as many photos as you really can.
I would personally recommend getting between minimum 150 photos to, after that, as many as you want. As many as you think your computer can handle and render afterwards.
So all we're going to do is we're going to keep going through there. We're going to keep rotating, taking more photos. Again, guys, I really don't want to include too many cuts or edits, just so you guys can see how, in real time, how fast it is.
So what I actually do is now I pause it and I reposition myself somewhere where I could better get the actual concrete post at the bottom, because as I was going I realized that I wasn't really getting the full height and depth of the object. So I pause it and I'm going to continue to get more of a diverse, I guess, array of pictures, making sure that I get the bottom pose, making sure I get more of the actual back supporting beam, and I continue to circle around the object to get as many photos as I can. Okay, and that should be all for this recording. And then I also made sure to include the thorns that were poking me the whole time, just so you guys can see, where I was walking through, and I have an excuse for not having the most stable footage. But now we're in the back end, and now you can see some of the options for processing the object, some of the quality settings, and we're gonna go ahead and select one so that we can render our object and we can see the fruits of our labor. Now I did break my own rule, and I did edit a cut into this because the processing did take about 15 to 20 minutes. But this is our finished object. As you can see, it's very high detail, it's very high fidelity. It's a pretty good object. It even captured most of the environment, and it even got a glimpse of my scooter that I use to get there. But we can see it captured some pretty good detail on the ground, some pretty good detail in the actual cement pillar on the bottom. And then once we zoom in and see more of the object, you're gonna see that we got a good amount of the pole. A lot of the objects like the padlock and the graffiti, in the actual like fine details in the object of the actual texture, it's all there. So again, photogrammetry is a really good alternative to LiDAR if you don't have an actual LiDAR scanner. A lot of these apps actually have a lot of functionality. For example, right here I'm measuring the object just for fun to see how realistic it is. I can't remember exactly how tall it was, but I think that's pretty accurate. But all in all, for being outside for 10 minutes, taking multiple scans, I think this was a pretty successful trip. Here I am just playing with more of the options where I could go in first person field of view and pretend like if I'm there at the park again. But yeah, I mean, this object is pretty high fidelity and I'm pretty satisfied with it overall. And now I actually want to do a little comparison between this scan that we took right now using photogrammetry and the scan of the like water runoff that we took with LiDAR. As you can see right now, there's pretty good detail with in the concrete and the actual metal. I want to say lid that we see with the LiDAR scan. You can see the pores in the concrete. You can see just how corroded and how rough the actual metal is, as well as a lot of details in the dirt. But photogrammetry also did a really good job too. But I think it's important to keep in mind that you guys saw every second that it took to create the LiDAR scan compared to this photogrammetry model that took 15 to 20 minutes of post-processing. But again, the detail right here is really good. I mean, we can see the details in the hinges where it opens up. We can see the padlock, but both models look overall really well. It's just finding which use case works for you and your budget, because Polycam only gives a certain amount of free scans. So
Staying on the track of photogrammetry, I want to show you guys a different way to do it. Here you can see my screen again, and on my Google Drive that I have built with a lot of photos that I took of the scene. I downloaded these photos, and as you can see this, it's the exact same process I was doing earlier. I rotated around the object, taking hundreds of photos. Well, in this case, more like 150, roughly. Just to kind of show you guys more of the low scale, more of the quick and easy. And I'm gonna take those photos to actually open up this application called Mashroom.
now Mashroom is a free app that is incredibly helpful.
That allows you to really simply and somewhat fast make a 3D model out of these photos. So here I'm going to bring back my window. I'm going to select all the photos and I'm going to drop it into the bin on the left. Sensitive, 1 second. And now you see them all there. So I'm going to quickly scroll through all of them so you can see that those are the same photos. I'm going to I might click right here on the metadata just so you guys can see some of the camera settings that I have. Yeah, here you can see like the camera settings that I was using on my smartphone. And you know, like you can do this on anything. I mean, I recorded the LiDAR on my iPhone, but I took these pictures with my Android, and now I'm on my computer to create this process. So what I'm going to do is I'm going to press start, and it's very important to save the file. Guys, it's really important to put this file in somewhere that you're not going to forget about, because this is how you're going to access your model later. So I went ahead and I put it into a folder, and I'm going to press start again. Now you could make some small tweaks into the bottom nodes to kind of help out in render time, but all in all, this is going to take a very long time. But in the bottom, you can see the progress of where you are. I think for this model, it took me a good, I would say 2 to 3 hours. But my desktop is specified like a workstation. But even on my gaming laptop, this takes me a good while. So just let your computer sit and render your object out. And I'm going to have a timer here showing the progress. Right here we see the progress in about 1 hour and 14 minutes in, and you can see where we're at so far. We're about a little less than halfway, and you can see where the model has begun to kind of start creating a point cloud. Checking it again at a minute and 35. No, an hour and 35. I'm sorry. And now you can see the updated point cloud. We're a little under 3/4, but I'm going to go ahead and keep going. So I did have to go fall asleep, but I did leave my computer all night running the program, and it took a while. But here we have the finished render. Now, from this view, it might not seem like a pretty good model, right? But that's because it's not here. The way you actually export a model is going back into your save settings. So going back into the folders that we were at, you're gonna see a new folder called Mashroom Cache. You can open up texturing, and you should see a new folder there. On the right side, we're gonna click on the textured OBJ, and this is gonna take a second for me to open right now, just because again my computer has been running all night and it's in need of a restart, so it's a little bit overloaded. But when this does open, in a few more seconds, we're gonna see more of the updated model with all the textures and everything. Here we go. So using the Windows 3D viewer, we can see here our model. Now I want to point out that might not be as high fidelity as the other models that we took out using the LiDAR or the photogrammetry, but when you're working on the computer, it's a little more important to pay attention to the details of, say, your camera settings, the distance, and a little bit of the render settings. So because we did the very fast, not paying attention to too much details, because I just wanted to show you guys the process. this is the model we got. It's still pretty good, but it could be improved. That's what I'm trying to say. Now at this point, you could bring in your model into any 3D modeling software that you'd like. I like Blender, so that's where I'm going to actually open it at. So what I'm going to do is I'm going to actually import the model. And once again, I want to reiterate how important it is to have a good file management system. I know we're into that because especially in Mashroom, there's no explicit export option. You just have to kind of know where it's at and how to find it. But one thing about Mashroom is that it does give you log files. So if you do forget where you put your files at, your working files, yeah.
What you could do is use that logbook to actually use a file path to find the files, in case you didn't save your project, like I told you to.
Here we see our actual model. Now, traditionally in Blender, when you first open up an object, you're going to see it in grayscale, but that's fine. That's just the view that we're in. But what you can see is that here's the actual topography of the scan that we took. Here's the actual model, the mesh that was created. And then if I change the views, what you can see now is the texture is being applied to it. And from here, I have free range to edit this as much as I want, and editing the colors, the hue, cropping it, and I can then bring that into virtual reality. Here I want to show y'all is different object that I created using a different program. This one is called Reality Capture. This was my go-to program for a long time, but the thing is it's not free. Every project costs a few pennies to $1. But as you can see right here, the point cloud and the mesh for the object I was able to create here was actually really good. But now I want to be honest. I created this object using the same exact method that I did for the pole, but I had a little bit more control with the lighting and the environment in this object. So that's a big reason why it looks so much better. I was able to properly control the lighting, so it wasn't as many shadows or overly exposed spots. But I did use the exact same device, the same phone that I used. Ideally, you would want to use a DSLR camera so you can have better control of all the camera settings to be as consistent. But again, guys, this is just trial and error and just trying to find out what works with the equipment that you have. But yeah, as you can see, this was a really nice high fidelity scale model that now could be exported. I believe this export was like $1.50 USD, but that's photogrammetry and LiDAR. That's the 101, the quick breakdown. A lot of the stuff is just practicing and getting out there. But if you have guys have any questions, let me know.